For this lesson, we're going to review integration techniques that we've already tried out. So I want you to try out A, B, C, and D by yourself, and then press play when you're ready to see the solutions. So the first one was arctan, then we had several ln's where you had u prime over u, and then we had general power rule for part D. Try out A and B for example 2, and then check your solution. Part A is just u prime over u. ln of ln x. For part B, we're using reverse chain rule. You can substitute the u's in like I did, or you can just jump straight to power rule for integration. There are several algebra techniques that make integration easier. For example, maybe we can't use reverse chain rule, but we could literally just expand a binomial and then use the power rule to integrate. If you have a fraction and your denominator is a monomial, divide each term separately. If you have a fraction where the degree of the denominator is the same or is less than the degree of the numerator, then you should use long division. For number 3, u prime is not present. So I can't use reverse chain rule, but since this is only to the power of 2, I'm going to expand. Now I can integrate each term separately. Remember the integral of e to the u prime is e to the u, but u prime has to be present. So we need a 4 for the first one, and we need a 2 for this one. I'm just going to split this 4 into a 2 times 2. Remember, you can always check by deriving your answer, and you should get your integrand. Number 4 is a fraction all over a monomial, so we can separate each of these terms by dividing them by the denominator. And integrate using the power rule. For number 5, the degree of the numerator is the same as the degree of the denominator, so we need to use long division before integrating. An equivalent integrand would be 1 plus our remainder over our divisor. In fact, our remainder's numerator has a negative in both terms, so I'm going to factor that negative out by making it minus 2x plus 1 over x squared plus x. Then I'm going to split those into 2 integrals and integrate separately. Now I can integrate. U is x squared plus x. U prime is 2x plus 1, so we have u prime over u, which is ln absolute value u. Unfortunately, we can't get rid of the absolute value because if x is an integer, then yeah, the result will always be positive. But if x is a fraction, then our result would have a negative inside of the log, so we need to keep the absolute value on there. For number 6, I might be able to use reverse chain rule. I might be able to use arcsin, but I have multiple things in the numerator, so I'm going to split this fraction. Our very first one is arcsin, especially if we take that 3 and put it in the front. So 3 arcsin. For our second integral, we can use reverse chain rule. So I actually want a negative 2x. I'll put that negative back into the integrand, throw a 2 inside and a 1/2 outside. Add 1 to the power. And there's our answer. For number 7, we have e to a function of x, so perhaps we have e to the u prime. Let's check. Pretty close. Let's multiply in a negative 2 and a negative 1/2. Now we have e to the u. For number 8, it almost looks like we have u prime over u, but tangent x is being squared. So perhaps we have arctan u prime over u squared plus a squared? Let's check. We do indeed have u prime in the numerator, so this is arctan. And there's our answer.